In this lesson, we're going to learn about a step function, which also might be called a greatest integer function. Our one problem we're doing for this is just to kind of introduce us to what this graph looks like. It's one you haven't seen before, and so if you see one again later, you might recognize it a little quicker. So the problem is Perfect Plumbers charges $40 per hour or any fraction thereof for labor. Draw a graph of the step function that represents the situation. What this means is if a plumber comes to my house for 15 minutes, they're going to charge me $40. If they come for an hour and a half, they're going to charge me $80. So they don't charge and multiply $40 times however many hours with a fraction that they've been there. They round to the nearest hour. So how we would set this up is I'm going to say that my x value is the number of hours the plumber's at my house. My y value is the money charged, so total charge. I'm going to make an XY table to help me understand how this works. So right away I hope you realize that the first hour is 40 bucks, or like 0 times to an hour, right? So the second they come to my house up to an hour is $40. Then after 1 hour up to 2 hours is $80. What I'm not sure maybe how to do is how to write that time period that they charge $40 for. So they charge $40 when they come to my house 0 hours, well, right after 0 hours, all the way up to 1 hour. So how I would write that is with an inequality. I would say if they're at my house less than or equal to 1 hour, it's going to be $40. If it equals 1 hour, it's $40. If it's 1 hour and 1 minute, it's $80, right? But if they're at my house 0 hours, I don't pay anything. So I'm going to say x is greater than 0 because after 0, I pay 40 bucks. Not equal to 0 because at 0 they aren't at my house and I pay nothing, right? So then the next, so this is what this is saying, this inequality right here, is that between 0 and up to 1 hour, so including 1 hour, I would pay $40. So that pattern is going to continue for each hour that they come to our house. Between 1 hour and 2 hours, I'm going to pay $80. So not equal to 1 hour, because if it's exactly 1 hour, it's 40 bucks. But greater than 1 hour, and then less than or equal to 2 hours, I pay $80. If it is 2 hours to exactly 3 hours, I pay $120. If it's 3 hours to exactly 4 hours, I pay $160. So that's what a table would look like for that. The interesting part is how to graph this. I know that I'm only going to have values at the 40, 80, 120, 160 marks. I'm not going to have any that are between there. So no graphs will happen in this area at all. They'll only be on the line. So as I do that, I'm going to look and say, okay, so for my first hour, if I'm looking at my x-axis here, from 0 to 1 hour, I pay $40. So in between here, I'm paying 40 bucks no matter what. At 1 hour, I pay $40. At 0, I pay nothing. So I'm going to put an open circle there to signify that I'm not paying anything then. And I pay 40 bucks all the way across until I hit an hour, and I'm still paying 40 bucks, close circle. 2 hours, I'm paying $80. Everything before 2 hours, I'm paying $80. But at 1 hour, I don't pay $80. I pay 40, which is why I have the circle in red below. This is where they get the notion of a step function. Every step is the same way. I don't pay 160 for 3 hours, but anything after 3 hours, I pay 160 for. I don't pay 1 or 200 for 4 hours, but anything after, I pay $200 for. So if you look at this graph for a second, you will see, I hope, that it looks like a staircase. That's where they get the name step function from. This isn't something that you're going to have to remember. It'd be a great bonus question, but it's something I wanted to introduce you to because you will see this every once in a while, and so you can kind of see how that flows. One question people might have is it a function? You know, we call this a step function. For it to be a function, it should pass the vertical line test. So as I draw this line through here, take a look. Am I ever touching 2 points at once? And the answer is no. I hope you can see. Right here, some people might think I am, but this is an open circle, not touching there. That's where I'm touching, is that closed circle.